So we looked at organizing the elements into metals, nonmetals, and metalloids. Now we're going to look at different ways to classify the elements. On the periodic table, you'll notice that at the very top, there is a group number. Like in this case, it's 1A. That's hydrogen, lithium, sodium, potassium, so forth. Here's 2A. 3A is all the way over here, 4A, 5A. And we're talking about the columns. So everything in 1A, we're talking about this column right here. 3A, we're talking about this entire column right there. And so forth all the way over to 8A. And then in the middle, you have your B groups. And the B groups are kind of start off a little different. This is 3B, and 1B is all the way over here. But your B groups are right here in the middle. So we're going to name the A groups, just the A groups. Each A group has a specific name. So, for example, group 1A is called the alkali metals. These are very reactive. They're found only in compounds in nature. So we're talking about lithium, sodium, potassium, that group right there. Now you're not going to see just a piece of sodium in nature because it's very reactive. So it's found in compounds. Group 2A, alkaline earth. These are beryllium, magnesium, calcium, and furthermore in that group. Just like group 1A, these are very reactive. They're found only in compounds. So you're not going to find a piece of magnesium lying around in a meadow somewhere. Group 3A. Now we're jumping all the way over to boron, aluminum, gallium, that group. That's called the aluminum family. That's not too bad. It's got aluminum in it. Group 4A is called the carbon family, and it starts with carbon. You got carbon, silicon, germanium, and so forth in that group. And remember, if they're in the same group, they have similar properties, so they behave very similarly chemically. Group 5A are called the pnictides. This starts with nitrogen, so you got nitrogen, phosphorus, and so forth in the pnictide group. Group 6A is the chalcogens. That starts with oxygen, sulfur, selenium. Group 7A, halogens. You've probably heard that terminology before, halogens. These are all diatomic elements, which means it's not just F in nature, it's actually F2, and that's because it's more stable combined as two elements in a molecule. So you got F2, you've got Cl2, you've got Br2, and so forth. But these are all diatomic, which means there are two atoms combined together. And then group 8A are the noble gases. And if you look on the periodic table, they are all gases at room temp. They're all outlined in the red. So you've got helium, neon, argon, and so forth down that column. So those are the names of the 8A groups that you need to know. Just another way to classify elements. Here's yet another way to classify elements. So we have metals, nonmetals, metalloids. You have the 8A groups, and here's the third way to classify elements based on their electron configurations. We can classify elements into one of four categories. Noble gases. These are unreactive because they have completely filled S and P subshells. This is group 8A. They have completely filled subshells, which means they are very stable. For example, neon. Neon's configuration is 1s2, 2s2, 2p6. This is the outer shell, 2s and 2p. It's completely full with 8 valence electrons. And anytime you have 8 valence electrons, it's very stable, noble gases. Groups 1A through 7A, just the A groups, not the B groups. 1 through 7A, the S and P subshells are not filled, so these are called representative elements. We're going to look at a couple examples, calcium and sulfur. If I do the electron configuration, we'll do calcium first. Calcium's electron configuration, if you do shorthand, would be argon 4s2. Now the group number equals the number of electrons in the highest occupied energy level. What that means is calcium is in group 2A, which means calcium has 2 outer shell electrons, and we call these valence electrons. And from the electron configuration, you can see where the 2 comes from. So calcium's in group 2. It has 2 valence electrons. Sulfur. If we do the shorthand notation for sulfur, we could start with neon. So we could say neon, and then it'd be 3s, 2, 3p, and sulfur would be 3p4. If you count up the number of valence electrons, there's 2 there, there's 4 there. That's a total of 6 valence electrons. And sulfur is in group 6A. So the group number and a representative equals the number of valence electrons, outer shell electrons. So let's go to the periodic table again. Here's what we have. Noble gases, right there. Noble gases. Representative elements, all the A groups. So we got representative over here, and then these 2 over here are also called representative elements. So that's your 1 through 7A groups. Now, what we have left are the B groups, the ones right here in the middle, and the ones here at the bottom. Those are B groups as well. B groups have their own name, transition elements. Now, if they're in the main body, they're called transition metals. If they're in the d orbitals. If they're below the periodic table, the 2 rows below the periodic table, f orbitals, those are called inner transition metals. So, we have 3 ways to classify elements. Metals, nonmetals, metalloids, that's one way. Second way is we can name the A group, alkali, alkaline earth, and so forth. And then the third way is based on the electron configurations.